Hello, Joshita. Good evening, good evening, good evening, Joshita. Good evening, good evening, Joshita. Good evening. Anyone is in the live? Good evening, Subhana. Good evening, Ashrita. Good evening, Amit Dubey. Right, right. Still anyone in the live? Good evening, Stun. May I know who is this Stun? Who is this Stun? May I know who is this Stun? Oh, Prashant. Good evening, Akshara. Good evening, Prashant. Good evening, everyone. Right, right, right. Now, next. Now, today's lecture, we are going to. Good evening, Janakiram. Good evening. Good evening, Janakiram. Good evening. Right. Now, mm, now we'll start the class. Now, in the last class, we have studied up to the where we have done up to the de Broglie wave equation, right? Now, in the de Broglie wave equation, now how it is related with the kinetic energy, and we have seen the some type of the questions also we have seen. Now, in this lecture, we are going to see about the which one Heisenberg uncertainty principle. Now, what is the meaning of the Heisenberg uncertainty principle and what he has given here in this Heisenberg uncertainty principle? Now, the scientist he has said that exact position and the momentum of the electron cannot be calculated. Means what he has said, the exact position and the momentum of the electron cannot be calculated. It is Heisenberg uncertainty principle. Heisenberg uncertainty principle. In this Heisenberg uncertainty principle, here we can't determine the exact position and the momentum of the electron, right? Done. Now we can't determine the exact position and the momentum. For that one, he has given one formula. Now del x into del p greater than or equal to h by 4 pi. H by 4 pi. Done. Now here we know momentum, uncertainty in the momentum is equal to mass into uncertainty in the velocity. Then this formula we can change it into the in this manner also. Uncertainty in the position into mass into uncertainty in the velocity greater than or equal to h by 4 pi. Right? H by 4 pi. Done. Now here the del x is nothing but uncertainty in position. Now here the del P is equal to uncertainty in momentum. Clear? Now here the delta V is equal to uncertainty in velocity. Clear? Now these are the some uncertainty principle questions this is the formula we are having. Done. Now we'll do one question based on this one with the uncertainty principle, so that now see the question carefully. Now read the question carefully and give me the answer. Okay. If the uncertainty in the position of a moving electron is equal to its de Broglie wavelength, then its velocity will be completely uncertainty. Then its velocity will be completely uncertainty when completely its uncertainty will be when it will be completely uncertainty will be when. This is the one question. Now try to take the screenshot of this one. Now we'll solve this same question at the last. Okay, at the last try to take the screenshot of this question. Okay, next one, another question, because we have to cover the more the number of content as well as more the number of questions on the quantum numbers, right? Now the next question we are having now. A microscope using suitable photons is employed to locate an electron in an atom within a distance of 0.1 angstrom. What is the uncertainty involved in the measurement of its velocity? These are the two questions we are having. We'll discuss at the last. Now try to take the screenshot of it. Clear? Now once you remind me, so that I can we'll do the questions based on that one. Now right, the one who are in the live, once you say me here, after we cannot find the uncertainty in the position of the momentum and the electron, then the next we are going to see the which one, Here exact position and the momentum of the electron we cannot be find. Then after that the de Broglie has proved that electron is revolve in the fixed circular orbit, clear, in the form of the wave, and he has proved the mvr is equal to nh by 2 pi, which he has given by the Bohr. Then now my question is, now the scientists they want to catch the electron in the 3D space. For that one to catch the electron in the 3D space, now the one scientist called the Schrodinger, he has given the one wave equation, right? Now how that Schrodinger wave equation, from that Schrodinger wave equation what we have got, now we are going to discuss. Clear? Now first we know the matter is having the the matter it is having the good, who is this Shivani Raj. Now the matter it is having the two, right, one is a particle nature. Matter it is having the two natures, one is a particle nature and one is a wave nature. One is a wave nature. When the electron is behaving like the particle, we can find its location because its a position is fixed. Its a position is fixed. Now if the electron, if it is present in the any atom, its position of that electron is fixed, so we can find it in that. Sir, I just read the whole chapter and my mind is blunt like all the derivation equations are theories by all the scientists. Now, actually, atomic structure is a one beautiful chapter because here first all the failed theories will come. Then after the every beautiful successful theories it will come with the proper reason. Actually, they are finding. See, in the one success we will not get right. The doing the many of the sessions we are getting the different thing. First electron, next proton, next neutron, next nucleus, then atom, then it is revolving like a wave and everything. Now, here comes on say, yeah, that only. Now the particle nature, if it is fixed, now when the electron is revolving in the 3D space, when the electron is revolving in the 3D space, clear, like a wave, then the position of that electron is not fixed. Okay, for that one just to be in a line so that I can show you one 3D so that it will be easy for you. Be in a line. Okay, just now you can see. Now I brought the one 3D model so that it will be very useful for you. Now the quantum numbers, everything I will explain. Right. Now, here, if the electron is revolving in the 3D space like a wave. Now, what is the meaning of the 3D space? Now, how it is revolving like a wave? Now we'll see. Now we can see, now this is a 3D space. Okay. Now let assume, or better we'll take the, now this is a 3D space, right? Now in this 3D space, you can see electron here, either it can be travel like a wave in this x-axis. If you consider this as a red as a this red as a x-axis, okay, this red as the x-axis. Now in this manner also it can travel electron, in this manner also it can move. Now in this manner also it can move. You can see about the axis, any direction it can move in the 3D space. In the 3D space, electron can move either in the x-axis or either in the z-axis, either in the y-axis. Clear? Now in the 3D space, the catching of the electron is very much difficult. We don't know whether it is traveling in the x-axis or whether it is traveling in the y-axis or whether it is traveling in the z-axis. In which axis it is traveling, we don't know. Now for that one, clear? Now to get the exact position of the electron in the 3D space, to get the exact position in the electron in the 3D space, now there was a scientist called the Schrodinger. He has given one beautiful equation so that we can find the exact position of the electron in the 3D space. Now for that one, what he has given? No. Wave nature. If the electron, if it is having the wave nature, then it will show the two types of the nature, right? Now, wave nature means position is not fixed. Position not fixed. Now, position not fixed means it is moving from one location to the one location. Which axis it is moving, we don't know. To catch the exact position of the electron in the 3D space, now the Schrodinger, he has given the one equation. Now, can anyone say the Schrodinger wave equation? Okay. There is a difficulty to type the entire Schrodinger wave equation in the chat. But I will ask you one thing. After writing the Schrodinger wave equation, I will ask you some terms. You have to say me. Okay. Now the Schrodinger wave equation he has given dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V into psi is equal to 0. This is a Schrodinger wave equation he has given. Then may I know here to calculate the, what is the meaning of this psi? To calculate the position of the electron, we have to solve the wave function. What? To calculate the position of electron, we have to solve the wave function psi. Clear? Done. Now may I know what is the E here and what is the V here? Can anyone say me what is the E here and what is the V here? Can anyone say me what is the E here and what is the V here? Anyone who is in the live? What is the E over there and what is the E and V? What is the E and V over there? V is potential energy. Good. V is potential energy. Right. Next. Good, Nana. Good. V is potential energy. Next one. Good, Subhana, good. Joshita, good. Amit Dubey, good. Akshara. E is total. Yes. E is the total energy. E is the total energy and V is the potential energy. Clear? Now, by solving this Schrodinger wave equation, we got the exact position of the which one? Electron. We got the exact position of the electron. Now, by solving this Schrodinger wave equation, how many quantum numbers it is came? Now, what is the role of the quantum numbers and how many quantum numbers it has came? Quantum numbers is nothing but here. What is the meaning of the quantum numbers? Quantum numbers is nothing but to calculate the exact position of the electron in the 3D space. Clear? Now, by solving the Schrodinger wave equation, how many quantum numbers we got? Can anyone? By solving the Schrodinger wave equation, how many quantum numbers we got? By solving the Schrodinger wave equation, how many quantum numbers we got? Three. Good, Amit Dubey, good. Three quantum numbers. Fourth quantum number is experimentally given. Good, Subhana, good. Now, by solving the Schrodinger wave equation, we got the three quantum numbers. Now, three quantum numbers. First one is the principal quantum number, that it is represented by the small n, and the second one is a azimuthal quantum number, that it was given by the small l. Clear? And the third one is a magnetic quantum number. And that it was given by the small m. Clear? And the fourth one is a spin quantum number, that is given experimentally. This is given experimentally. Given. Right? Now, we'll see now one by one. Now, what is the principal quantum number? What is the azimuthal? And what is the magnetic quantum number and the spin quantum number? Already we know here electron is will not present in orbit, it will be present in the orbitals, right? First electron will present in orbit. In that orbit we are having the subshells. Now in that subshells we are having the which one? Orbitals. In that orbitals electrons will be there. This we know. Clear? Right. Now in the same way we know, if you want to catch your friend, already I was explained you very clearly, which if you want to catch your friend, then first you have to know your friend state name. In that state we have to know the district. In that district we have to know the city. And the city, now your friend's house number is experimentally given by the different cities. But these three are fixed, right? These three are fixed. In the same way, principal quantum number, azimuthal quantum number and the magnetic quantum numbers. Now these three are derived experiment. These are fixed and it has came from by solving the Schrodinger wave equation. And the last S is the principal quantum number experimentally given. In the same way like the house numbers, that it is given by the different cities. Clear? Now we'll see one by one quantum number, and based on that we'll solve the n number of questions so that it will be clear for you. Right. First one is a principal quantum number. I wrote it is a principal. Actually it is a principal. Okay, now the principal quantum number small n, right? Now here this principal quantum number, its values lies from n 1 comma 2 comma 3 comma 4 comma so on up to infinity. Here the n should not be equal to 0. n should never will be equal to the 0. This is very, very important. Here infinity, up to the infinity it will go, because if you consider the entire world, now in the entire world how many states we are having, we don't know. So that's the reason we used to say that infinity states. Done. Next. Clear? Now this, it is denoted by n. It is denoted by n. Next. What are the significance we are having for this one? Good evening. Good evening, Ashwan. Good evening. Be focused to the class. Okay. Good evening, Vishnu. Be focused to the class. Now, what are the significance we are having? Now we'll see. It gives the information about, it gives info about energy levels of the orbit. Energy levels of the orbit. Now what are the energy levels of the orbits that we are having? The n is equal to 1, 2, 3, 4. Now the energy levels. EL means energy levels. Energy levels, that is n is equal to 1, we used to say K, this is L, this is M, and this is N. Clear? And it gives the information about the size of the, orbital also. Clear? Now, done. Now this is about the principal quantum number. Done. Next. It tells, next one. Azimuthal quantum number. Next one is a azimuthal quantum number. Azimuthal quantum number, small l. Clear? It is denoted by the L. Now its values lies between 0, 1, 2, 3 so on up to n minus 1. Now you have to be very careful here in the principal quantum number that n value should be always greater than which one? Always greater than L. Clear? Sure. That's the reason only. Let me finish. Now, let me finish the quantum numbers content today. Tomorrow, we are going to do the entire atomic structure questions from the cathode rays to last. What? Last up to the exchange of energy. What exchange of energy? Half filled orbital, fully filled orbitals. Still up to there, I will explain. Or I will do the question session tomorrow. Clear? Now tomorrow at the live, I will schedule at the 5 or 5:30. I will schedule the live in the channel. You can see over there. But today, max to max, I will try to finish the questions on the based on the quantum. Based on the quantum, I will try to finish the questions. Okay. Right. Tomorrow, max 5. 5 is the class. So that we can do the n number of questions and it will be helpful for your Monday's exam. Portion, it will be helpful for you. Okay. Now its n value should be always greater than L and n should not be equal to L, or L value should not be equal to the n, and L value should not be greater than n. This is a very, very key point you have to remember. If you remember this key point, If you remember this key point, whatever may be the question they may ask, easily you can predict. What easily you can predict by this question? What this concept, if they have given, easily you can predict. Done? Right? Now, next. Here, the significance he has given, it gives info about subshells. It gives the info about subshells. Clear? Subshells in which electron belongs. In which the electrons belong. Good evening, Rumana. Good evening. Clear? Here the if that subshells means here if the L value is equal to 0 and L value is equal to 1, if the L value is equal to 2, if the L value is equal to 3, and the name of the subshells. Can anyone say me the name of the subshell? If L is equal to 0, what is the subshell name? If the L is equal to 1, what is the subshell name? If L is equal to 2, what is the subshell name? If the L is equal to 3, what is the subshell name? If the L is equal to 0, what is the subshell name? And if the L is equal to 1, subshell name. L is equal to 2, subshell name. N is equal to 3, subshell name. Can anyone say me? If L is equal to 0, what is the subshell name? If N is equal to 0, what is the subshell name? Yes. Yes. P, D, F. Good. Good, Nana. Good. Joshita. Good, Amit Dubey. Right? Now, this is a SPDF. This is a SPDF. Right. SPDF. Good. And next. Here we'll see the shapes of that orbitals. Shapes of orbitals. In the yes, good, Nana. Yes, SPDF. Yes, good. Now, here, if shapes of the orbital, if L value is equal to 0, that we call it as a S, and that S we call it as a spherical. Now, spherical in the sense, here, this is in this spherical region only we can find the electrons. Now, if the electron, if it is present in the S subshell, we can find the electron only in this, which one? Spherical region only. Now, next one. If L is equal to 1, then that is a D, and we say it as a dumbbell shape. Now, the dumbbell shape will be in this manner. Now, in this lobe only we can find the electrons. Done. Next one. L is equal to, this is L is equal to 1. If the L is equal to 2, that is here p orbital. Now, L is equal to 2. L is equal to 2, that is a D. We say it as a double dumbbell. That is double dumbbell. Now, here the lobes will be in this manner. Now, here the electrons will be there in the double dumbbell. And the N is equal to 3, that is a F orbital, and that is a fold axis we used to say. Right? Now, next. Next, he has given the one formula of orbital angular momentum. Orbital angular momentum is equal to root L into L plus 1 H by 2 pi. This H by 2 pi, sometimes they will give you in the form also H cut. H cut is equal to H by 2 pi. Here the formula we can define under root L into L plus 1 H cut also. Now, can anyone say me what is the orbital angular momentum of? Clear? Now, what is the orbital angular momentum of? Which one? 3D series element. What is the orbital angular momentum of 3D series element? Can anyone say me what is the orbital angular momentum of 3D series element? What is the orbital angular momentum of 3D series element? What is the orbital angular momentum of 3D series element? 3D series. 3D series element orbital angular momentum. What is the orbital angular momentum of 3D series element? Can anyone? What is the orbital angular momentum of 3D series element? Good. Root 6 h by 2 pi. Right. Now here the d value is L is equal to 2, right? Now if you put it in this formula, then what it will get? 2 into 2 plus 1, that it will give you the 3, that it will become the root 6. So root 6 h by 2 pi. Root 6 h by 2 pi. Good. Subhana, good. Root of 6 h by 2 pi. Good. Good Akshara. Good Vishnu. Good. Right. Now the next we'll move to the magnetic quantum number. The next one we are having the magnetic quantum number. Magnetic quantum number M. Then this magnetic quantum number M. Right? Now here the magnetic quantum number has been denoted by the small m, and its values lies between m is equal to minus L, comma 0, comma plus L. Minus L, comma 0, comma plus L. Here what it will do, it describes the orientation of the orbital. What it says about orientation of orbital. It says about the orientation of orbital to find the electron. Now where the electron, finding of the electron is maximum. Finding of the electron is maximum in that orbital. Now if suppose here it means the three orientation of the orbitals, if I take the maximum probability of finding the electrons are in the which one? Orbitals only, right? That orientation of the orbitals will be given by the magnetic quantum number. Now I will ask you, let's suppose if the electron is present in the n. Now how many possible L values we are having? Clear? Then after that, and which subshell it is having, in which subshell it is having, then after that, now what are the possible M values? Clear? And after that, number of orbitals you have to say. Clear? First of all, if n is equal to 1, what are the possible L values? Already I explained you very clearly. N value should not be equal to L and it should not be greater than L. But what is the L value? N value enta undo same L value kuda ante undali. Ante n is equal to 1 ante L kuda oka value undali. Kani a value n kante takko undali. Now you say me. Good. Then if the n is equal to 1, L is 0. Now if the L is equal to 0, which subshell that is? If the L is equal to 0, which subshell? If L is equal to 0, which subshell? If the L is equal to 0, that represents which subshell? Good Yashwant, good. If n is equal to 1, that is L is equal to 0. If L is equal to 0, that is which subshell? 1s. Now that is S. Good. Subhana, good. That is S. Yes, good. That is 1s. Good. Spherical, good. That is 1s subshell. Now what are the possible M values? What are the possible m values? What are the possible m values? Yes, good. First option. Now my question, what are the possible m values? M values. What are the possible m values? 0. Good. The possible m values are 0. It indicates that only one orbital it is having in the S. That orbital is 0. Yes. Total number of orbitals are 1. If the electron, if it is present in the n is equal to 1 orbit, now it is having the only one subshell, that is n is equal to 1s subshell, and its orbitals, number of orbitals are 1. Right? Now next, if the n is equal to 2, if the electron is present in n is equal to 2, now possible L values, how many possible L values we are having? Any L values, any subshells, what are the possible L values and total number of orbitals? Good, everyone, good. Akshara, Vishnu, Yashwant, Joshita. Now the possible L values are 0 and 1. Now if it is a 0, that we say it as a 2s. If it is a p, that we have to say it as a 2p. If it is a s, we know only possible m values are 0. Yes, good, Amit Dubey. And the possible m values. Can anyone say me what are the possible m values for the p? What are the possible m values for the p? Yes. What are the possible m values for the p? What are the possible m values for the p? What are the possible m values for the p? N is equal to 2, L is equal to 0, SL and 1 P subshell. Okay, now good. That is a -1, 0 and the +1. -1 and the 0, +1, right? -1, 0 and the +1. Right. Now total number of orbitals in the n is equal to 2. If the electron is present in the n is equal to 2, total number of orbitals. Total number of orbitals orbitals are 4. Good, Vishnu, good. Total number of the orbitals are 4. Right. Now we'll see with the 3 here. Now if the electron is present in the n is equal to 3, now what are the possible L values? If the electron is present in n is equal to 3, what are the possible L values? What are the possible L values? If the electron is present in n is equal to 3, what are the possible L values? Right, good, Akshara, good. 0, 1, 2, 0, 1, 2. Yes, good, Ashwant, good. Now, here that is a subshell. Now that subshells are, one is 3s, one is 3p, one is 3d. Right? Right. Good. Right. Good. Next one. Now the m values are here the 0. Now here it is a -1, 0 and +1. Now when it comes to the d, here it is having the -2, -1, 0, +1, +2. Total number of the orbitals are total number of orbitals is 9. Yes, good, everyone, good. Now if the n is equal to 4, yes, good, Vishnu, good. If the n is equal to 4, good, Akshara, good, everyone. Yashwant, Vishnu, Joshita, Amit Dubey, and Subhana. Now that is 0, 1, 2, 3. That is 4s, 4p, 4d and the 4f. Now here it is a 0, -1, 0, +1. Here it is a -2, -1, 0, +1, +2. Now here it is a -3, -2, -1, 0, +1, +2 and the +3. Now the total number of the orbitals are 16. Total number of the orbitals are 16. Good, good, good everyone. Good, Nana, good, good, good. Good, good everyone, good. Now the next one, the fourth type of the quantum number, we are having the spin quantum number. Fourth type of the quantum number, it is a spin quantum number. In that spin quantum number, if the electron is revolving in the clockwise or plus of, or we used to give the half arrow. If the electron is revolving in the anti-clockwise, now that is a minus of and it is a below arrow. Yes, good, good, good. Total 16. Right, right, right. Good, Anna, good, good, good. This type of the answers and this type of the response will make me boost so that I can give you the more the content so that it will be helpful for your academics. Right? Now here we will see. Now in the orbit, now we will see. Here this is a nucleus. If the n is equal to 1 orbit, if they have given, in the n is equal to 1 orbit, we are having only one subshell, that is a 1s. In that 1s subshell, we are having only the 1 orbit. It is having the only 1 orbit. Good, good, Akshara, good. If n is equal to 2, if they have given, that is 2s and that is a 2p. Now we know S we are having 1 and the p we are having 3. Right? If n is equal to 3. The n is equal to 3 if they given, right, 3s, 3p and 3d. Now 3s we are having 1, 3p we are having 3 and 3d we are having 5. Right? Now here the n is equal to 4. Now we know that is 4s we are having 1, 4p we are having 3. Next 4d we are having 5. Now next one 4f we are having total 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right. Total, yes. Total this many orbitals we are having. Now here the problem we got that we know that electron is present in these orbitals. By that we have captured the electron in the 3D space by knowing the quantum numbers of that electron. After knowing the quantum numbers of that electron, the next thing we are going to see how the electrons are filled in these orbitals. Now the next one we are going to see how the electrons are filled in the orbitals. For that one we are having the 3 principles to be followed to fill the electrons in the which one in these orbitals. If that electron, if it is following that principle, if all the electrons, if it is following that all the 3 principle properly, then if the electron will be added in that orbitals, clear, by following those rules. Now what are those 3 rules that electron is following? Can anyone say me? What are the 3 rules that electron is following to fill in these orbitals? To fill these electrons in this orbital, what are the rules that electrons should follow? That we call it as the energies of the atomic orbital or representation of the electrons. That we call it as a electronic configuration. To write the electronic configuration or electrons to be filled in the orbital, now it should follow some rules, right? What are the rules I am asking? What are the rules it should follow? What are the rules it should follow? What are the rules that electrons should be followed? No, not update. No. Is my question is clear? I was asking, now this many orbitals we are having, right? Now in this many orbitals, electron will be first enter into the which orbital to write the electronic configuration of that element. First is the Aubos principle. Yes, good. Aubos principle, Pauli's exclusive principle, and the Ans rule. Good, everyone, good. Akshara, Joshita, Amit Dubey. Right. Now the heading is representation of the electronic configuration. Electronic configuration. Electronic configuration. Right? Electronic configuration. Here, now this electronic configuration, the electrons filled in orbitals, the electrons filled in the orbitals must obey the following rules. Must obey the following rules. First one, of Bohr's principle. First one is the of Bohr's principle, right? Second one, Pauli's exclusion principle. Right. Sir, voice is not clear. For everyone, is it same? Now the voice is clear. What the vision is not clear? Everyone, is everything is okay? Everyone, it's everything is okay. Voice, screen, and everything it is okay. Yes, sir. Okay, right. Then the third one, it should follow the Un's rule. It should follow the Un's rule. Yes. Next is the Un's rule. Yes. Right. Okay. Now, first one, the first one he has given Bohr's principle. The first one, the Bohr's principle. In this Bohr's principle, what he has given, the electron will first enter into those orbitals which is having the lower energy. He has given, now the electron first enter into those orbital whose n plus L value is less. Clear? Here we are having the yes. Here we are having the so many orbitals, right? Now we'll see. Here the 1s, here the 2s, here the 2p, here the 3s, here the 3p. Clear? Now we'll see which orbital is having the lower n plus n value. Based on that lower n plus n value, we have to fill the electrons. Now first one, what is the n plus n value of 1s, and what is the n plus n value of 2s, and what is the n plus n value of 2p? Now what is the n plus n value of 2p? Now say me, what is the n plus n value of 1s, and what is the n plus n value of 2s, and what is the n plus n value of 2p, and what is the n plus n value of 2p, and what is the n plus n value of 3s, and what is the n plus n value of 3p? And what is the n plus n value of 3p? What is the n plus n value of 1s? 1s is good, Subhana, good. 1s is 1, right? 2s is, now 2s is 1, 2, 3. Now next 2s, 1s, 2s, 2p, 3s, 3p, n plus n values you have to same. 1s is 1, good Akshara, good Yashwant, good Joshita. 2s is 2, right? 2p is 2p 2 2p 2s is 2, 2p is 3. Why? N value is 2, L value is 1, right? We know L is equal to 0, that is S. L is equal to 1, that is P. L is equal to 2, that is D. If L is equal to 3, that is F. Right. Here 2p, 3. 3s we are having, that is 3 plus 0, that is 3. 3p we are having how much? 4. Now you can see here the 2p as well as 3s. 2p as well as 3s we got it as a same n plus n value. Then if the 2p and the 3s, if we are getting the same n plus n value, then here the one rule you have to follow. What? If orbitals having, sir, my answer 1 2 3 3 4. Good Yashwant, good Yashwant. But hello Neeraj, hi Neeraj. Now hi and hi to the classes, welcome to the classes, and be focused to the class. If you are, may I know from where you are from and which stream you are, and you are preparing for JEE or you preparing for NEET, and where are you from? May I know? Right. Here, if the orbitals having same n plus n value, if orbital having same n plus L value, if orbital having same n plus n value, clear? Now, the orbital with higher n value, orbital with higher n value will have higher energy, This is a one very key point you have to remember. Good evening Bindu. Hyderabad means good evening. Okay, you can now, may I know you are in the class 11th or class 12th? May I know you are in the class 11th or class 12th? May I know you are in the class 11th or class 12th? Right. Clear? These are the one very key point you have to remember. The orbital having same n plus n value, orbital with the higher n value will always have the higher energy. Clear? Done. Right. Next, the example 2p and the 3s. Here the n plus n value is 3. Here the n plus n value is 3. Clear? Then 3s is having the higher energy. Next one we are going to see that in the 3p and 4s. 3p and the 4s. 3p here the n plus n value is 4. Here the 4p n plus n value is 4. Here what it is having? Now 4s is having the higher energy than the 3p. Clear? Done? Right. Is it clear? Done? Now. Then after that, the next we are going to see a very important point, that the energy of orbitals for hydrogen and hydrogen-like atoms. Energy of orbitals for hydrogen and hydrogen-like atoms. For hydrogen and hydrogen-like atoms, we are having energy order E is equal to 1s less than 2s equal to 2p. No. Right. Now here 1s less than 2p equal to, now here 3s equal to 3p equal to 3d less than 4s equal to 4p equal to 4d equal to 4f. Clear? And so on. Good, Vishnu, good. Right. Now, this is a one very key point you have to remember. So they will make you confused by giving the question. Like sometimes they will give you the what is the energy order for the helium. If they ask what is the energy order for the helium, then you have to follow the energy order, that is 1s less than 2s less than 2p less than 3s less than 3p less than 4s less than 3d and so on. If suppose the same thing, if we ask for the He plus ion, what is the energy order for He plus ion, then you have to follow this energy order. So you have to be very careful in the what type of the question he is asking. So you have to be very careful with the question he asks. According to the question data, we have to solve. Clear? Done. Right. Now the next one we are going to see, that is Pauli's exclusion principle. The next one we are going to see, that is a Pauli's exclusion principle. Now, what is the meaning of the Pauli's exclusion principle? He has said that no two electrons should have all four quantum numbers same. No two electrons should have all four quantum numbers same. For that one, now we'll see the orientation of the orbitals. If I was taking the one 3s orbital or not, one 3s orbital I will take. For this 3s orbital, first I will fill the electrons in this manner in the one orbital. Now the same orbital I will fill the electrons in this manner. For the next I will fill the electron one above, one below. Next I will fill the electron in the one below and below. Now we'll see. All the four quantum numbers should not have same, right? Now if I want to write all the four quantum numbers for this electron, what I will get? N is equal to 3, L is equal to 0, M is equal to 0, S is equal to plus half. Now if I write all the four quantum numbers for this one also, N is equal to 3, L is equal to 0, M is equal to 0, S is equal to plus half. Now you see all the four quantum numbers it has given same, right? So this orientation is wrong. Now when you come to this one, here the N is equal to 3, L is equal to 0, M is equal to 0, S is equal to plus half. Now but the middle electrons if you write, then here the S is equal to minus half you will get. But this electron and this electron same quantum numbers you will get. So this is also violated. What he has said, no two electrons should accommodate the three electrons. Done? Now when it comes to this one, when it comes to the second one, here the N is equal to 3, L is equal to 0, M is equal to 0, S is equal to plus half. Now if I write the same quantum number for this one, 3, 0, 0, but S is minus half. So this orientation is correct. And here it will become the minus half and here it is the minus half. Now by that he got to know that orbital can accommodate only two electrons with a opposite spin. Clear? Only this orientation is correct. Next one, the third one is unruled. Next one is a unruled. Now what is the meaning of the unruled? Unruled, what he has said, if electron want to pair, now it should occupy one electron first in each orbital. Each orbital it should occupy one electron first, right? Now how it should occupy each electron in one orbital first? Now we'll see here. Here if I take the P3, here the orientation if we'll see in this manner. Now the second orientation we'll see in this manner. Now the third orientation we'll see one above, one below, one above and one below. P4 will take better. Right? Now, here to calculate the orbital orientation or the how much orbital orientation it is having, that we can calculate by the 2s plus 1. Here the s is plus of for the above spin and the minus of for the below spin. Now, here if I calculate the spin multiplicity of this orbital, I will get spin multiplicity for this one. Here the above plus of 0, above plus of 0. So 2 0 plus 1, 2 0 plus 1, it will give you the 1, right? It will give you the 1. What happened, Amit Dubey? Anything, any problem? Now here the plus of minus of 0, this one plus of, this one minus of 0, this is plus of and this is plus of. I spin yes, good, or maximum spin multiplicity. Now it is 1, so 2 1 plus 1, it will give you the 3. Now here plus of minus of 0, here the minus of and the plus of 0, again it will get the spin multiplicity 1. So by that he has given that electron want to pair, it should occupy one electron first in each orbital. Electron should occupy one electron first in each orbital, then only the pairing will be happened. Now by that we have to fill the electrons in the orbitals. Now we'll see. Here the first two, here the hydrogen. Hydrogen, how to fill the electron? We know 1s orbital. Now helium, that helium, one orbital can accommodate 2 electrons. Each orbital should occupy the 1 electron, then only it should be paired, right? Then next if we go for the lithium, that is 1s2 and it is a 2s1. Next beryllium, if you go, that is 1s2 and it is a 2s2. Clear? Next one, if you go for the boron, it is 1s2. Next here it is a 2s2. Next one it is a p, right? Here the 2p1. Next carbon, if you go, 1s2, 2s2 and we are having the 2p2. Here it is a 2p1. Nitrogen, if you go, 1s2, 2s2 and we are having the 2p3. Clear? Now this, then only after the oxygen, for the oxygen here the pairing will be happened. 1 2 3 4. Here it will be the 2p4. This one will be the same. Right? In this manner you have to fill the electrons. Now the one only the exceptional electronic configuration that we are having, that I will explain, so that rest all you can try it from your end. The exceptional electronic configuration, that is a chromium, that is we are having the 1s1, 1s2, 2s2, 2p6, next 3s2, 3p6 and it is having the 4s1, 4s1 and the 3d5. And the 3d5. Clear? This is a 3d5. It is a 4s1 and it is a 3d5. Next one is a copper. This will helpful for you in the which one? Finding of the magnetic momentum. There it will be helpful for you. Clear? Next one is a 4s1, 3d10. 3d10, right? Clear? Now this is about the which one? Writing of the electronic configuration of the different orbitals or elements we got to know. Then next one, the very important that we are having, that is paired and unpaired. Paired and the unpaired. Paired in the sense, now if the orbital, if it is filled with the electrons, if all the orbitals are filled with the electrons, that one we call it as a paired. That one we call it as a paired, right? If the unpaired electron means if one electron also, if it is not filled in the orbitals, if the one electron is also not filled in the orbitals, that we call it as a unpaired. That we call it as a unpaired. Clear? This is a unpaired, and this one we call it as a paired. Done. Now next one we are having the diamagnetic and paramagnetic. Now what is the meaning of the diamagnetic and the paramagnetic? For the diamagnetic, if the mu is equal to 0, that is diamagnetic. If the mu is not equal to 0, that is paramagnetic. Sir, what is the mu is equal to 0? What is the mu not is equal to 0? Now I will say. Now to calculate the magnetic moment, mu is equal to under root n into n plus 2 Bohr magnetons. Under root n into n plus 2 Bohr magnetons, right? Now here the n is equal to unpaired electrons. Now I will explain it for the 2-3 molecules. Now for the remaining molecules you have to say me. Here I will go for the now we will go for the Cu, okay, Cu and Cu plus and Fe plus 2 I will go. Now Cu, if you write copper electron, here we will go with the chromium. Right? Now copper electronic configuration is 4s1 3d10. Done. Here the unpaired electron is present in the 4s. So here the n is equal, here the d10 is completely filled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here we are having the one unpaired electron. Now can anyone say what is the magnetic moment mu value for the Cu? What is the magnetic moment mu value for the Cu? Can anyone say me what is the magnetic moment mu value for the Cu? Can anyone say me what is the magnetic moment mu value for the Cu? And Cr and Fe and Fe plus 2. Both. 1, 2, 3, 4. Can anyone say me what is the magnetic moment mu value for the Cu as well as Cr plus Fe plus 2? Can anyone say me the answer? Can anyone say me the answer? Can anyone say me what is the mu value for the Cu, Cr plus Fe plus? Cr plus is root 35 Bohr magnetons. Cu is root 3 Bohr magnetons. Yes. Root n into n plus 2, right? 1 plus 3. So root 3 Bohr magnetons for the Cu. And the rest one Cr plus, it is a root 35 Bohr magnetons. Root 35 Bohr magnetons. Good. How? 5 plus 2. It will give you the 7. 7 5 is root 35 Bohr magnetons. No, root 35 Bohr magnetons. Cr plus is a root 35 Bohr magnetons. Fe will be 4, right? 4 into 6. So root 24 Bohr magnetons. Root 24 Bohr magnetons. No. 4 unpaired, right? Fe plus 2. Fe and Fe plus 2 both are having same. No. Cr plus is root 35 Bohr magnetons. My dear friends, you have to be very careful. No, Cu 4s plus 1, right? One unpaired electron it is present here. So due to that, its Bohr magnetons are 3. Then Cr plus, it is having the 35, root 35 Bohr magnetons because its electronic configuration. If I write the electronic configuration for the Cr plus 1, if I write the electronic configuration for the Cr plus 1, then it is a argon 4s1 3d5, right? One electron should be removed from the valency electrons. Now if I remove the valency electrons, it will become 5, right? Now Fe plus 2, here again the unpaired electrons, here it is how many? Here if you write the electronic configuration, that is argon 4s2 3d6. Then if the 2 electrons are removed from here, again the 4 unpaired electrons will be there. That 4 unpaired electron 4 into 6, that will give the root 24 Bohr magnetons only. Clear, in all the cases it is a root 24 Bohr magnetons only. You have to be very careful with this one. You have to be very careful with the root 24, root 35 Bohr magnetons only. Now why you are getting confused? Should I explain or you are getting confusion? The one who are in the live, should I explain? Should I explain? Should I explain or is it clear for you? For everyone, is it clear or should I explain? Is it clear or should I explain? Should I explain or is it clear? Cr. No, Cr is root 35 Bohr magnetons. Yes, root 35. Now we'll see the questions based on the quantum numbers. Now we'll see the questions based on the quantum numbers. Now how the questions they will ask you. Now what is asking? Here the question is asking rest. Find the all four quantum numbers for the all four quantum numbers for the unpaired electron of atomic number 55. Now semi. Calculate the all four possible quantum numbers of unpaired electron of atomic number 55. Yes. Maybe they have went. They will come. They will come. No problem, Vishnu. Just be studious to the studies. Irrespective of the live, if the one student is also there in the live, I will explain. Okay. If the student, if he is one also, I will explain. Right. Semi. Find the all four quantum numbers for the unpaired. All the four quantum numbers. Anyone is in the live? The one who are in the live, can anyone explain? If anyone is in the live, try to give me the answer. If not, give me the question mark, I will explain. If not, give me the question mark, I will explain. Okay. You can solve. You can solve. Subhana is saying how, sir. Subhana is saying how to solve. Raj Reddy question mark. Okay. Should I explain? Uh, Joshita is saying that I was trying. Now listen. Here, what does it mean means, here the atomic number 55. Atomic number 55. Atomic number 55 is of which one? Now, already I explained the one trick. Helium, neon, argon, krypton, xenon, radon, OG, right? Here it is 2, this is 10, this is 18, this is 36, this is 54, and this is a 86, and this is a 118. Now this is a 56, right? This is a first period, second, third, fourth, fifth, sixth, seventh. Done. Now xenon is coming under the fifth period, right? Now the 55 will be comes under the sixth period. That is hydrogen, lithium, sodium, potassium, rubidium, and the cesium. Now here one atomic number 1, 3, 11, 19. Next one here it will be the 36 means here it is a 37. Here it is a 55. 55 is the cesium. 55 is the cesium, right? Now for this cesium he is asking all four quantum numbers. Now here the what I said, atomic number 55 to 86. Now all the elements will be present in the, yes, good Nana, correct. Akshara, correct. N is equal to 6, L is equal to 0, M is equal to 0, S is equal to plus of, correct. Akshara, it is correct only. Now he is asking the for the cesium that unpaired electron is present in. That cesium that unpaired electron is present in which one? So the cesium that unpaired electron is present, the N is equal to 6, L is equal to 0, M is equal to 0, S is equal to plus of. Clear? Is it clear? No. Now, next type of the question. Yes, good. Next one, the next question, it is somewhat tricky. Now listen. Possible subshells for n plus L value is equal to 7. Possible subshells for n plus L is equal to 7. Now semi. How many subshells are possible with n plus L is equal to 7? How many possible subshells for n plus L is equal to 7? How many? How many possible? Now you have to semi. How many possible subshells? How many possible subshells? How many possible subshells for n is equal to 7? What are there? What are the possible subshells? What are there? I'm asking what are there? I'm asking 4 only, but I'm asking what are there? I mean like S, S, P, D, F, which S, like we know, right? 1S, 2S, 3S, 3P, 4S, like that. With the n plus L value, what are that 4 subshells or 3 subshells, whatever we are getting? Now what are they? What are those orbitals? I'm asking. Orbitals AV. Good, Subhana, good. One is 7s, one is 6p, one is 5d, and one is a 4f, right? Yes. 7s, n plus L value is 7, 7 plus 0, it is 7. Next one is a, which one? 6p, 6p, n plus n value is 7, 6 plus 1, 7. Next one, 5d, n plus L value is how much? 7, 5 plus 2. Next 6f. Now n plus L value is how much? 7, 6, 4f. 4 plus 3, that is 7. Yes. Now. Yes. 7s, 6p, 5d, 4f. Good. Next one. Next question. Now maximum number of electrons in the possible subshell for n plus L is equal to 4. Okay, in this n plus L is equal to 4, how many possible subshells will have? In that subshells, how many electrons will be there? Yes, Nada, good. Ashrita, Vishnu, now Akshara, Joshita, rest other, any other who are trying and who are seeing the live also. Now say me the answer. What is the maximum number of electrons in the possible subshell for n plus L is equal to 4? Maximum number of electrons that maximum subshell, the maximum number of electrons. No. Good. That is one is a 4s and one is a 4p. So the total number of electrons are how many? No, Janakiram, no. No. Amit Dubey, good Nana, 4s and 3p. And total number of electrons, are is asking the maximum possible electrons, right? No. Subhana, 2D and 1f orbitals will not be exist. Already I said you very clearly. Here the n value should be always L value. Here the 2 and 2. It is not at all possible. So 2D is not at all possible. And L is greater than L. Then 1f is not at all possible only. So only the, yes, good. Good Yashwant. Only the possible n values are 4s and the 3p. 4s and the 3p. S can accommodate 2, p can accommodate 6. The total number of electrons are 8. Total number of electrons are 8. Good, 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 everyone. Good, good, everyone, good. Yes, yes, good, 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 good. Everyone, good. Now, next one. Next one is asking. Now, next one. Impossible. Next, good, good, good. Next one. Impossible quantum numbers. Now, which quantum number is impossible? Here the N, L, M, S. Option A. 3, 2, minus 2, half. Next B. 4, 0, 0, half. C. 3, 2, minus 3, half. D. 5, 3, 0, half. Now, sim. Which of the following orbital is impossible to arrange? Impossible quantum number. Which one is impossible to arrange? Good, good, Subhana, good. That is C. Yes, H1 C. Good, good, good. This C. Right, right, right. C. Yes, good, good, good. C. Because here the L is 2 and the possible M value is possible M value. If the L is equal to 2 means the possible M values are minus 2, minus 1, 0, plus 1 and the plus 2. But plus 3 it is not at all possible only. Good, Nana, Arshita. Ashrita, good, good, good. M is not correct in the option C. Good, good, good. Good, good, good. Everyone, good. Next one. Next question. Next question is asking decreasing order. Decreasing order of energy. Decreasing order of energy. Now, for the orbitals, which orbital is having the lesser from the higher to the lower, or you can write it as like higher to the lower energy orbital. Higher to lower order of energy. Now, here the n is equal to 4, L is equal to 0, M is equal to 0, S is equal to plus half. Right? B. N is equal to 3, L is equal to 1, M is equal to 1, S is equal to minus half. Now C. N is equal to 3, L is equal to 2, M is equal to 0, S is equal to plus half. Now D. N is equal to 3, L is equal to 0, M is equal to 0, S is equal to minus half. Now sim. Good, Akshara, good, 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 good. Now semi. Lower energy from the higher to lower energy of orbitals. From the higher to lower. CABD. CABD order. CABD. Good. C. Now Janagiram has said that CABD. Bindu, like Joshita is saying C. CABD. Now here this n plus n value is 3D. Here the n plus n value is 5. Here the n plus n value is 4. Here the n plus n value is 4. Now here the n plus n value is 3. So the C is first. Then after the among the A and B, if the n plus n values are same, the one which is having the higher n value is having the same. So A, then after B, and the last is D. Right. Good. So the answer is C greater than A greater than B greater than D. C greater than A greater than B greater than D. Right. Good. Next one very interesting question I will ask you. Is saying magnetic moment of mx plus magnetic momentum of mx plus magnetic moment of the mx plus is root 15 Bohr magnetons. Okay, then is asking the number of unpaired electrons and the value of x is the number of unpaired electrons and the value of x is the number of unpaired electrons and the value of x is the number of unpaired electron and the value of x is. This is one very interesting question. The number of unpaired electron and the value of the x is. What 3? Yashwant is saying number of unpaired electrons are 3. Oh sir, number of unpaired electrons are 3. Anime boy is saying what 3? Janagiram is saying 3 x 3. X 3 x 3 no 3 unpaired electron. No, listen, I will explain. Now listen. Here if this type of the question if they are given, here the mx plus is asking and that it will be equal to the root 15, right? Root 15. Clear? Now you see. Right. Here, right, we are having the formula root n into n plus 2 Bohr magnetons. That will be equal to the root 15. Then when will be the root 15 will be happen? When the n will be equal to if the n is equal to 3, then here the 3 into 5 Bohr magnetons will give you the root 15, right? Then the n value is 3. Then it indicates that number of unpaired electrons are 3. Okay? Right? The number of unpaired electrons we got it as 3. But is asking what is the x here? What is the x value? So that the number of unpaired electrons will become 5. Then the x value, now we'll see. If an element its x value to find, That one, let's suppose if we are taking the atomic number of chromium, let's take chromium. If suppose we are considering this element is a chromium 24 or 25 or 26, okay, 24, 25 and the 26 we are considering. If the atomic number 24, then it will give you the when and which oxidation state, or when the power, what is the power to give you the 15. Now atomic number chromium is having the argon 4s1 3d5, right? Then to give the number of unpaired electrons, how many electrons I have to remove from the chromium? 1 and as well as 2. Here from the 2, 1 electron from here and the 2 electron from here. If I remove, then m plus 3 it should be there. If the atomic number means 24 means m should be plus 3. If the atomic number 25 means that is which one? Manganese, that is Ar 4s2 3d5. Then again to give the how many 3 unpaired electrons I have to remove from here 2, and I was to remove the 2 electrons from here, and it will become the m plus 4. Clear? Then m into the plus 4, the number of unpaired electrons will be 3 for the atomic number 25. Then atomic number 26 means iron, that is Ar 4s2 3d6, right? Now, how many electrons I have to remove? I have to remove from the 2 here. Done. Then after that again, how many electrons I have to remove? 1, 2, 3. Total 3 electrons I have to remove. Then it will become m plus 5. M plus 5 will be the oxidation state if the element is 26. Clear? In this manner you have to be very careful, but many of the cases they will provide the atomic number of the element. Don't worry, they will provide the atomic number of the element. X is also 3. No, X is 4. X is, if the atomic number is 24, 3. If the atomic number 25, 4. If the atomic number 26, 5. Is it clear? In that manner you have to cross check. Is it clear, or should I explain? Is it clear, or should I explain? Yes. I know. Yashwant, I know. It is 4:15. I know. Tomorrow is a Sunday only, right? And tomorrow, yes, at 5 o'clock will start, not 5:30. Exactly 5. Exactly 5. I am going to start the question sessions on the completely from the cathode rays to the which one, from the radial nodes also. The radial nodes class once I will revise tomorrow. That graphs of the radial curve and all tomorrow once I will clarify in the class, so that it will be very clear for you. And tomorrow, just my dear friends, now by the tomorrow evening, try to read all the content of the atomic structure, and before the 5 itself, try to finish your, if you are the beautiful bio, then try to finish the which one, bio as well as the physics, and the 5 you just be conscious with your pen and paper. Just by seeing the question itself, you have to read and you have to solve and you have to say the question to it. Okay? Evening only, evening 5, and the mains people also be ready with by the evening try to finish your content. Clear? Now by the 5 to 7 or 7:30, max to max 2 hours or 2.5 hours it will take, because it will be depend upon your speed of the questions. మీరు ఎంత స్పీడ్ గా క్వశ్చన్ చేస్తే అంత స్పీడ్ గా క్వశ్చన్స్ అయిపోతాయి. మ్యాక్స్ టు మ్యాక్స్ 45 to 50 క్వశ్చన్స్ ఉంటాయి కంప్లీట్ అటామిక్ స్ట్రక్చర్ గా. ఇక మళ్ళా మీరు అటామిక్ స్ట్రక్చర్ ని మళ్ళా రివైజ్ చేయాల్సిన అవసరం లేదు. దట్ అటామిక్ స్ట్రక్చర్ క్వశ్చన్స్ ఇఫ్ యూ డూ దట్ ఇట్ విల్ బి ఇన్ యువర్ మైండ్. ఓన్లీ మీరు ఒక పెన్ను పేపర్ పట్టుకొని ఉండాలి. అండ్ వైల్ సాల్వింగ్ యువర్ క్వశ్చన్స్ ఆల్సో డోంట్ సీ ఇన్ ద గూగుల్ ఆర్ నేనే ఫస్ట్ చెప్పాలి, సార్ని ఇంప్రెస్ చేయాలి. హియర్ మై డియర్ ఫ్రెండ్స్, యు ఆర్ నాట్ హియర్ టు ఇంప్రెస్ మీ. నేను మళ్ళా చెప్తున్నాను, యు ఆర్ నాట్ హియర్ టు ఇంప్రెస్ మీ. జస్ట్ ఫర్ సేక్ ఆఫ్ యూ ఓన్లీ ఐ వాస్ డూయింగ్ దిస్ ఆల్. మీకోసమే నేను చేస్తున్నా కాబట్టి ట్రై టు బీ ఫోకస్ చేయండి, మంచిగా చేయండి. ఏమన్నా రాకపోతే నాకు అడగండి, నేను చెప్తా. అంతేగాని గూగుల్లో కానీ అక్కడిక్కడ చూడకండి. ఓకే, టుమారో ఎగ్జాక్ట్లీ 5 విల్ స్టార్ట్ ద క్లాస్. ట్రై టు రివైజ్ ద కాన్సెప్ట్స్. ఫార్ములాలు మెయిన్గా ద మెనీ ఇంట్రెస్టింగ్ థింగ్ ఏంటంటే మనం ఫార్ములాస్ మర్చిపోతాం. ఫార్ములాస్, కాన్సెప్ట్స్, ఓకే, రేడియల్ నోడ్, యాంగులర్ నోడ్, హైసెన్బర్గ్ అన్సర్టెనిటీ ప్రిన్సిపల్, నెక్స్ట్ డి బ్రోగ్లీ, అవన్నీ. ఓకే, రైట్. ఓకే మై డియర్ ఫ్రెండ్స్, విల్ సీ యూ టుమారో ఎట్ 5 షార్ప్లీ, సో దట్ ద మండేస్ ఎగ్జామ్, మండే రోజు మీకు ఏదేదైతే ఎగ్జామ్ ఇక క్వశ్చన్లు చూడగానే యూ హ్యావ్ టు బి డైరెక్ట్లీ ఫస్ట్ యూ హ్యావ్ టు స్టార్ట్ విత్ ద కెమిస్ట్రీ ఓన్లీ. అట్లా ఉండాలి. ఓకే, రైట్. నౌ ఐ వాజ్ ఎండింగ్ ద క్లాస్. స్టిల్ యూ ఆర్ హ్యావింగ్ ఎనీ కన్సర్న్స్? ఏమన్నా మాట్లాడాలా, ఏమన్నా అడగాలా? ఎనీ కన్సర్న్స్ ఇఫ్ యూ ఆర్ హ్యావింగ్ యూ కెన్ ఆస్క్. రిమైనింగ్ దే కెన్ లీవ్. If you are having any concerns, you can ask me. Anyone, if you are having any concerns, you can ask me. Anyone, if you are having any concerns, you can ask me. Remaining, they can leave. Should I end the live? Live end cheyana? Okay, done. Right. End chestunna live ni. I am ending the stream. Okay, good. Okay. Nayana, Vishnu, Sri Vishnu, I was not any topper in chemistry. Already I said. I was good in maths. I was good in which one? Physics. I was somewhat lagging in the chemistry, so that to become the pro in the chemistry, I was taken chemistry and I was studied MSc chemistry. Okay, I was not that much topper in chemistry as much as you guys. Okay. Okay, bye. We'll see you tomorrow. Bye Nana, bye. We'll see you tomorrow.